Alrighty. Let's review this a little bit. Jack, what is that? Derivative.
It's the slope of a tangent line on a line. Now it's bottom. Yeah.
Say curve?
Yes.
Okay. Ben, what else is it?
Instantaneous rate.
Logan, how do you figure it out? But I don't want the limit explanation. So if I gave you something, what's one way you could figure it out?
Put the thing in front.
So you put the thing in front of it. So let's say I gave you this. How would you figure out the derivative of that?
Do the
I didn't hear anything you said, so.
chain rule?
Not yet.
No, I
You could use a chain rule.
that's what
I wouldn't, but okay. Can you write an exponent for that? Can you write x to some power?
3 halves.
3 halves. Would that be easier?
Yeah.
Okay. And then you would use a method in which you'd write 3 halves here. Is that right? And x to the 1/2 here.
Yeah.
Okay, what do we call that?
I don't remember.
Okay, that's fine. Zach, do you know what we call that? Where we multiply and subtract 1? Power rule, right? Okay, well, that's fine. I mean, it's not important that you, but you understand the process, correct? Zach, what if I gave you this? Would you use the power rule there? No, you'd have a different rule, correct? And you would come up with what is the answer. And if you're not sure, it's on the board. Cosine x. You'd use one of the rules for trig, correct? All right. So power rule, a trig rule. Cooper, I'm going to give you this one. How would you do that one?
For that, you have to use chain
I didn't hear anything at all. I'm sorry.
rule.
What?
Chain rule.
Chain rule. So you're actually, when you do the chain rule, you incorporate the power rule and the rule that you have in trig, correct?
3 halves times the thing in parentheses, and then leave the thing in parentheses alone, and do that times the derivative of
So this becomes 1/2.
yeah, and subtract.
And then you got the derivative of the inside, which is cosine of x, right? All right, now, in all of these, the exponent was a constant. Would you agree? Okay, so what we're going to do is we're going to take, what I'm saying here is x, our input value, is not an exponent. It's something else. Like here it would be an angle measurement. Here it'd be some real number, but it's definitely not an exponent. And so what we're going to look at is how to take derivatives of logarithmic and exponential functions. Like, how do we take the derivative of this? That's our question. What's the derivative of something like that? We will not use the power rule. I'll give you an example. At the end of the class, we'll take the derivative of this. That one right there. And you'll be probably on Friday's quiz, which will be really short, so you'll have plenty of time to get it done. And this is what people will do, because they love the power rule so well. They'll take x, multiply x by this coefficient, and get x. And then they'll write x again, and then they'll subtract 1 from x. That's the most common wrong answer that I see. The problem with that is this is x to the first, isn't it? Correct? And the bases are the same. And when the bases are the same, what do you do with the exponents? You add them, right? So when I add them, I get x, and I get 1 plus x minus 1. What do I get? I get the same thing. I haven't done anything at all. And there is a function that's true, and we'll get to that today also, but it's not this one. So this has to be approached a different way. Does that make sense? So we're looking at how we're going to take derivatives of stuff that are exponents. All right? So I want you to look at these notes. By the way, remember this note, whoever gave me this? Okay. I just saw it was Matt because I forgot who it was. So this is some review because we did that packet. And x equals log base 10 of 100 means that 10 to the x equals 100. Correct? That's what it means. And this would mean x to the third equals 8. Correct? And so the inverse of y equals 3 to the x is x equals, and this is wrong, log base 3 of y. And then when you interchange them, the x and the y, you get this. Correct? Okay, so they're inverses of each other. One undoes the other. So then I give you some properties. The log base b of 1 is 0 because b to the 0 is equal to 1. Here's that expansion rule. Here is taking that exponent, multiplying it out in front. And here's that subtraction rule. So these 4 rules right here are going to be the most important rules that we're going to use today. All right? So let's just review this. This was also in the packet. Cooper, do you remember? You didn't do the packet because you haven't seen the packet. Okay? Packet was my wife's favorite color, which was purple. I don't know if I'll be able to do that for you, but I'll see if I can. Okay? Do you remember doing this last year?
Yeah.
Okay, can you tell me how to do it? You're going to need a calculator.
Okay.
And we should get the same answer both ways. And if you don't remember, that's fine. Nathan remembers. He just nodded his head yes.
I believe, I'm not sure about all of it, but that would be, would rewrite it as a log, right?
I wouldn't. What I would use is I would use this rule right here. I will use logs, but I'm not gonna write it as a base 17 log. See, everybody else has the advantage. They got their calculators out like they're machine guns. So the people in the abyss are just saying, oh my gosh, he's violent. Which is probably true. What? Okay, Nate. What would you do? Okay, so you're going to use the log base 10, which is just log on your calculator, right? So he's going to have x log 17 equals log 92.5. And so x equals log 92.5 divided by the log of 17. Do you remember something like that? Okay, so the only way we can solve for an exponent is by taking the log of both sides. That's what you got to remember. What did you actually come up with an answer, Nathan?
1.598.
1.598. Okay, the other method is rather than use the base 10 log is to use the, what do you think, Cooper? Natural log. So you can take the ln of 92.5, the ln of 17, and we will get exactly the same answer. And then this is a little bit of review. On your calculator, LOG, or in any reference, when we don't indicate the base, it's automatically base 10. And if we use the letters LN, that's base E. And base E is 2.17 something. 2.71828818284590 something. Okay? All right, so the back side, we're going to expand these. And Rayanne, can you expand that for me? 2 logarithms. Perfect. Natural log of 10 minus the natural log of 9. And Isabel, this is kind of poor, and I'm sorry about that. This is 3e squared. Can you expand that one to me, for me, please? I'll give you a hint, natural log.
Would be natural log 3
Yep.
plus natural log e squared, or 2 natural log e.
Like that? Perfect. Now, this, right, the 2 could come out front. What is the natural log of e? 1. So this is the same as the natural log of 3, and I'll put parentheses around it, plus 2. Correct? Ben, okay? All right. Michael, you got the best one. One of them, one natural log with something inside here.
Would be x to the third times y squared, then z to the negative 4.
Divided by z to the 4th?
Sure.
Is that what you said?
Yep.
It's a good thing I don't listen very well. It's a gift. Okay. Everybody okay on that? All right. So let me go back to my piece of paper here. For a long, long, long time in mathematics, here we have 1 over x squared dx. And you could write that as x to the negative 2 dx, right? And then we'd reverse the power rule, and we get x to the negative 1, and then we multiply by its reciprocal, which is a negative 1. And so we get negative 1 over x plus c, correct? Well, along came this one. Well, that's x to the negative 1 dx. Add 1, I get 0. And what's the reciprocal of 0? Well, it's a problem, right? We can't reverse the power rule because I get something over 0. Would you agree with that? So, mathematically, what we did, or I didn't do it, I guess I couldn't be part of it, but the natural log of x is defined as integrating from one number to another, 1 over t dt. So an example, and I have a few examples here. The natural log of 2 would be the integration of 1 to 2 of 1 over x dx. So I'm going to do that on my calculator. I've got 1 over x right there. Let me just graph that then. And there's the graph of it. And so I'm going to integrate. And I'm going to start at 1. And I'm going to go to 2. And as you see, it's going to shade that for a little bit, and I get 0.693 approximately. If you do the ln of 2, just straight ln of 2, do you get 0.693? So if I do the natural log of 3, I would integrate from 1 to 3, 1 over x dx. And there's my graph. I'll go calc, 7 from 1 to 3. You can see it shade in, and I get 1.099. Does that sound correct? And if I were to integrate a half. So if I think about this, really what I'm saying is e to some power equals 0.5. That'll have to be negative, wouldn't you agree? Because e to the first is going to be e, or 2.718. So if I'm going to need a negative answer as an exponent. Well, if I integrate that, I'm going to have from 1 to 0.5, 1 over x dx, but b cannot be bigger than a, so I have to write that as a negative 0.5 to 1 dx, correct? And if I do that on my calculator, I get a negative 0.693. Okay? All right, next page. Now, what does this mean? Well, what we're trying to do is, the purpose of today is see if we could figure out the derivative of the natural log. Because we know we're not going to use a power rule. So what I'm going to do is, and this is what is supposed to happen here, but I'll write a little bit nicer. I'm taking the derivative of the natural log of x dx, which means I'm going to take the derivative of this integral that goes from 1 to x, 1 over t dt, with respect to x. Now, when I take a derivative with an integral, they cancel each other out, correct? That means that function, oops, I made a mistake and I can see you guys looking at me. This should be t. That means that function stays the same. The only difference happens to what? What occurs, Jacob? Do you remember? Something replaces something.
Would it be the distance? Would it be b minus a replaces dx?
Well, this derivative and this integration cancels each other out.
Yeah.
I get this function, but t's not going to be in it. What's going to be?
X would.
Right. So my answer is 1 over x. So the derivative of the natural log is 1 over x. Well, what if I was doing this? The derivative, which is this one, the derivative of the natural log of 3x squared dx. Well, it would mean I'd be taking the derivative of the integral 1 to 3x squared, 1 over t dt, the derivative of that. And Logan, I'm going to get 1 over what? 3x squared times something. Do you know times what? Or you're not sure?
6x.
Yes, 6x. And that's 6x over 1. And so I got 6x over 3x squared. And that can simplify. 3 goes into 6 2 times. This x goes over x squared to x is 2 over x. So the derivative of the ln of 3x squared is 2 over x. Here's another way I can do this. I'm going to expand the natural log. Actually, Jack is. Can you expand this for me?
It's going to be 2 ln of 3 plus... No, it's going to be ln of 3 plus 2 ln.
Perfect. Okay. So, Claire, dy dx, what's the derivative of the ln of 3, do you think? Okay. What is the ln of 3? It's a what? It's a constant, right? What's the derivative of any constant? 0. Plus 2 times, what's the derivative of the ln of x? 1 over x. And I get 2 over x. Which is the same answer I got down here. The general form of taking the derivative of any natural log is the function is on the bottom and its derivative is on top. The function is on the bottom and its derivative is on top. So Jacob, what will go on the bottom?
X squared plus 1.
And what would go on top? What's the derivative of x squared plus 1?
2x.
2x. And you're done. I'm going to have another example over here. Y equals 5x cubed minus 17x. The natural log of. So the derivative, Braden, what would go on the bottom?
5x cubed minus 17x.
And what would go on top?
15x minus
15x
17.
what?
Squared.
Minus 17?
Yeah.
Minus 7. Does that make sense to everybody? It's not the power rule, is it? It's something different. The derivative of the function within the ln goes in the denominator. The derivative of that goes on top. So on this example, Riley, I have the chain rule. So what I have is I have a natural log inside a cubic function. So the first thing you're going to do is what? Using the chain rule. So you got 3 natural log of x squared, is that what you said?
Yep.
Times the derivative of the inside, which would be 1 over x. So this is 3 natural log of x squared over x. That's it. Destiny, big dot here, huge. Why? Why would I do such a thing? Why didn't I make a nice small tiny one? Or why did I just not put it in there at all?
There's gonna be 2 sets.
Yeah, I'm going to use what rule?
Product.
Product rule, perfect. So it's going to be x cubed times what? Notice I'm making a fraction right away. That's okay. You can put that on top.
Yeah.
Okay. What's on the bottom? Perfect. Plus, now you're going to have the natural log of x cubed minus 5, because you took that derivative already, right? Times what? 3x squared. So if I were to write that all out, it would look like this. 3x to the 5th. So I can combine those, right? Okay. Times, excuse me, x cubed minus 5 plus 3x squared times the natural log of x cubed minus 5. Okay? Pardon? Oh, how about that? Better? All right, Emily, I don't like square roots. Can I rewrite it or can you rewrite it so I don't get the square root?
X plus 1 to the 1.
Y equals what?
X plus 1 to the 1/2.
Right? What can I do with the 1/2? You're right.
Put in front.
Put in the front? Okay. So that means dy dx is going to be 1/2 times what?
X plus 1.
What?
X plus 1.
On the bottom?
Yeah.
And what on top? What's the derivative of x plus 1?
Just
1.
1.
So you could either write this as dy dx equals 2 times x plus 1, or write 2x plus 2. Matt, you got an awful one.
Oh, actually, I think
Because this, it would say, and some people will actually do this on Friday's quiz. They will go through and put this on the bottom and try to figure out its derivative and put it on top. But you know better than that because you're going to expand this for me first. I'll give you a hint. Natural log.
Oh, okay.
So ln of x squared plus, x squared plus 1 squared.
No, I'm not going to write the squared.
Okay, we'll put that 2 in the front then.
Okay?
Minus the ln, or 1/2 ln of 2x cubed minus 1.
Okay? So that means dy dx, and I'll slide it over, is equal to what?
On the bottom, it would be 2 ln of x squared plus 1.
Okay, what's on the bottom?
2 ln.
What's on the bottom? What am I taking? What's inside my natural log function?
Oh, x squared plus 1.
And what's on top? 2x times what? I agree, 2x
Oh,
times a what? What's out front here?
2.
2. So that will become 4x.
Yeah.
Okay, you see where the 2 came from? Minus,
Oh, okay. So on the bottom it would be 2x cubed minus 1.
can I multiply that by a 2?
Yep.
Because that's this half right here.
Uh-huh.
Okay, what's on top?
Top it would be 6x squared.
Okay, so now I could simplify this to say it's 4x over x squared plus 1 minus, this 2 goes into that 6, correct?
Yep.
Okay, and I get 3x squared over 2x cubed minus 1. And you do not need to get a common denominator. Okay, now you're going to see if you look at the answer key, Ben, can you very, very gently just shake his right shoulder for me, please? There you go. Thank you. All right. In the book, sometimes they'll get a common denominator, and sometimes they don't. It drives me nuts. So for me right now, you do not need to.
Or just leave it like that.
I would leave it just like this. The thing is, I do want you to take the 2 times the 2. I do want you to simplify when you can do that, but that's it. All right? So you can see these are exactly the same, almost. So Renee, can you expand that for me? What does y equal? Give you a hint, natural log.
Thank you. Y is gonna equal 2x minus the natural log of x squared.
You said plus?
What?
You said plus?
No.
You should say plus. I'm expanding, right? So right here I got x times, correct?
Yeah.
So it's going to be a natural log of x plus a natural log of something else. Right? I have 3 natural logs I can split up. Okay, because I have 3 separate functions inside there. Okay?
Would be, yeah, y equals ln x plus ln 2ln x.
Is that what you said?
Yes.
Okay.
And then minus 1/2 ln 2x cubed minus 4.
All right. So now when I take the derivative, notice this y becomes dy dx. Right, folks? Right, Isabel? That y becomes, when I take the derivative on the left side, where y is all by itself, it's dy dx, correct? Equals, what's this going to become? Renee, what's the derivative of the natural log of x? Perfect. What's this going to become?
Well, x squared plus 1 will be on the bottom, right?
Yep.
And the derivative of that times 2 will be on top.
Yeah, what would that? What's the derivative of that?
Well, 2x.
Times 2, right?
4x.
Perfect. Minus?
Minus 3x squared
Did you say, what did you say on top?
or, I'm sorry, 6x squared. So it would be 3x squared on top.
Oh, and then it's going to become 3x squared because of that 2?
Yeah.
Okay.
And
What's
then,
on the bottom?
2x cubed minus 1.
So you're done. Right?
Sure.
Okay. Backside. Now, a couple of things. See this absolute value around g of x? Sometimes your functions can give you negative numbers. You're never allowed to put 0 or a negative number into a logarithm because it doesn't make sense. E to what number gives you 0? There isn't one, is there? E to what number gives you a negative 1? There isn't any, is there? So what we do to protect the natural log from negative numbers is we change the function. So what we do is we put into absolute values so we know that the value is always going to be positive. All right? However, when you take its derivative, the absolute value symbols disappear because the derivative can be negative because it tells you where the function is decreasing. Does that make sense? So you don't have to do anything special. That's what I'm trying to tell you. All right? Marie, you ready? What goes on the bottom?
Cosine of x.
Okay. What goes on top?
Big sine.
And what's this the same as? You're done. Okay? Now, I'm going to give you 2 problems. Number 5. Actually, I'm going to give you several problems. Y equals, let's go 3x cube root of x to the 5th minus 1 over x to the 17th plus 23x. Now, Logan, this one's yours. Okay? Now, I apologize if this insults you, but this is god-awful. All right? Because this, you would have to do the product rule up here, the quotient rule, the chain rule, and the power rule. And this is ick. Okay? So I'm going to give you a little hint. We're going to take the natural log of both sides. And I'm going to have you expand that for me. I'll give you a hint, natural log.
ln of 3x plus 1/3 ln x to the 5th minus 1 minus ln x to the 7th plus 23x.
Perfect. Over here I got the ln of y. Okay, now I'm going to ask you to take its derivative. What's the derivative of this?
3.
Just 3? What goes on the bottom?
3 over 3x.
3 over 3x. Okay, agree with that. Which is 1 over x, right? Okay, you want me to just cancel out the 3's?
Sure.
It's kind of painful to do, but I will. I'm not going to use red because I'm kind of sad. Okay? What about this? Plus. That's a lousy 5, I'm sorry.
5x to the 4th
On top?
over 3 times x to the 5th minus 1.
Very good. Minus what?
17x to the 16th plus 23 over x to the 17th plus 23x.
Okay? You're halfway there. That wasn't bad, was it? Would you agree? That wasn't bad. Now here's the other part that you need to understand. And I'm going to, next couple of problems, I'm going to show you where we're going to use this. Same rule. What goes on the bottom? Y times. What's the derivative of y? Do you know, Logan? We're not sure. Jack, do you know? Jack, did I call on you today?
Yeah.
Okay. Jack, do you know the derivative of y?
Y prime.
Yes! What's another name for, and I used to use y prime, but my handwriting's so sloppy that students thought it meant y to the first power. But you're right, it's y prime. I'm not going to use the name y prime, you know, like prime rib. Okay? I'm going to use what instead?
dy
dy over dx. So every time you take the derivative of y, that's called implicit differentiation, if you recall, you have to put dy dx. So remember, we're trying to figure out what dy dx is, correct? So now I got dy dx all by itself. And over here I'm going to have 1 over x plus 5x to the 4th over 3 times x to the 5th minus 1 minus 17x to the 16th plus 23 over x to the 17th plus 23x that Logan did. I'm going to put them in these brackets, and I'm going to multiply it by y. I multiplied this side by y, I multiply that side by y. Are we okay with that step? Do I know what y is? I think I do. Because this was it right here, correct? So my final answer is going to be this. It's going to be bracket 1 over x plus 5 x to the 4th over 3 times 5, or x to the 5th minus 1, minus 17 x to the 16th plus 23 over x to the 17th plus 23x times, now I'm going to replace that y with 3x cubed root of x to the 5th minus 1 over x to the 17th plus 23x, and I'm done. And that's a lot better than trying to take using the rules. There are problems like that at the end of your assignment. There's problems like that on the quiz and the test. There's problems like that on the AP exam. So you have this. You take the natural log of both sides. You use your log rules to expand it. And then you take the derivative of each logarithm individually. Does that make sense? Let's take a look at this. Y equals x to the x. Remember I showed you how to do that wrong? So Kate, what I'm going to do is I'm going to take the natural log of this side. What would, if I take the natural log of this side, what does it look like?
X natural log.
Yeah, x times. Right, Kate? Times the natural log of x. Now, why did I emphasize times so much? What's another word for times that starts with a P? Yeah, product rule. So I'm going to take x times, what's the derivative of the natural log of x? 1 over x. Plus the natural log of x times the derivative of x. What's it? 1. So I get the natural log of y equals 1 plus the natural log, oops, I screwed up here, natural log of x. I didn't take the derivative on this side, did I? Kate, I screwed up. It's going to be 1 over y times what? Every single time. So that means dy dx is going to be this times y, which is 1 plus the ln of x. Y is x to the x. So that's the derivative of this. Two more problems. Y equals 2 to the x. How do you suppose I take the derivative of that? Nevaeh.
So first you take the derivative of y, which is 1 over y.
Well, I'm going to take the natural log first. But you are correct. I'm going to rewrite this so I got the natural log.
Okay, let it be x ln.
Perfect. Okay? So now, let's get back. What is this?
1 over y times y dx.
Okay, so do you know what this is right off the top of your head, or you want me to give you a little hint? Okay. What's the derivative of 3x? 3. Perfect. What's the derivative of x times 3?
No,
3. I just reversed them.
3. Yeah.
Okay. What's the derivative of 2x?
2.
2. What's the derivative of x times 2?
2.
2. So 3 and 2 are constants, correct? Is that a constant?
Yeah.
So what do you think the derivative of this is?
Just be
ln of 2. Because the derivative of x is 1, and you get 1 times the ln of 2. Does that make sense? Okay, so I get ln of 2. Okay, so what would be your next step?
multiply both sides by y.
So I get dy dx is equal to the ln of 2 times y, correct? So what's dy dx equal to?
ln of 2 times 2x.
Perfect. Jack, back to you. Okay? Y equals e to the x. I want you to figure out dy dx. What's the first thing you're going to do?
You take the natural log of both sides.
The natural log of y. And what will I have here?
X ln e, which would end up being 1.
ln of e is 1.
Yeah.
So the ln of y is equal to x.
Yeah.
Correct? Take the derivative of this now.
So then it's 1 over y dy dx equals 1, which means
Hold on, go slow. Equals 1. Okay? Which means what?
y equals dy dx.
dy dx equals y.
And then
What's y?
That's e to the x power.
E to the x. So e to the x is its own derivative. Okay, so I'm going to ask you a series of 3 questions. The first derivative of e to the x is?
E to the x.
Second derivative of e to the x is?
E to the x.
The third derivative of e to the x is?
E to the x.
E to the x. What's the next derivative of e to the x?
E to the x.
Okay.
X to 1 again.
Okay. You're okay here. Okay, you're okay here.
Yeah.
You're okay here.
Yeah.
Derivative of x is 1. Okay, now. That's the graph of y equals e to the x. Ben, this function increasing or decreasing? Increasing. That means its derivative, I'll call it y prime, has to be greater than 0. Is it? What's the derivative of e to the x? Is e to the x always positive?
Yes.
Yes, it is. Would you agree? Y double prime. Concave up, Ben, or concave down? That means the second derivative has to be positive, correct? What's the second derivative? E to the x. Is that always positive? See how it fits? Okay? Now, if you forget, by the way, we just went through 3 sections. One is, how do you take the derivative of e to the x? Okay. The next one is, how do you take the derivative of 2 to the x? Anybody have an idea? 150 to the x power. Anybody have a guess of what the derivative of that is? Just by looking at it? I'll give you a hint, starts with natural log. Natural log of what? 150 times what? 150 to the x. You're done. Nothing like the power rule, is it? Nothing like it. Why isn't it? Because the exponent is not a constant. The exponent is a variable. It's our input value, isn't it? All right? So tomorrow will be a work day. Yes, ma'am.
Will it actually be okay, or are you gonna give us
Asking the real questions.
I am giving no pop quizzes at this moment. I am planning on it being an actual work day. Okay?
Will that change at 3 in the morning?
I hope not. Please, please, Lord, let me sleep and not think of math. Yeah. No, I am highly anticipating, with great probability, Yeah.
I needed an exact percent.
No, it should be a
Is
work
P
day. I'm
less
pretty
than
confident.
0.05?
What?
Is P less than